This is called nature of the roots. For finding out the nature of the roots, we have to know the discriminant. Discriminant d equal to b square minus 4ca. b square minus 4ca. Here a is a coefficient of x and c is constant and b is a coefficient of x square. I said the standard quadratic equation ax square plus bx plus c. Okay, this is quadratic equation, and from this quadratic equation we can show the discriminant d equal to b square minus 4ca. Here b is a coefficient of x, a is a coefficient of x square, and c is constant, and we have to find out the nature of the roots, and for that we have to know d equal to 0. When d equal to 0, that means discriminant equal to 0, then we will say root are real. Okay, root are real and equal. Moreover, rational. Okay, real and equal. When d equal to 0, that means discriminant d equal to 0, then we will say root are real, equal, rational. And d greater than 0, d greater than 0, d greater than 0, that means d is greater than 0, then we will say unequal. Okay, roots are unequal but real. Okay, and when less than 0, discriminant less than 0, d less than 0, then we will say roots are complex but unequal. Roots are complex, and root will be like this: p plus root minus q, p minus root minus q. They will come conjugately. Okay, and when d greater than 0, d greater than 0, and perfect square. Okay, then we will say roots are real, unequal. Roots are here d greater than 0, here d greater than 0. Okay, but perfect square. Then if the discriminant be perfect square and greater than 0, then we will say roots are real, roots are unequal, rational. That means we have to actually think about 0 relation to the discriminant d. Okay, just when d greater than 0, then we will say unequal but real. Okay, and equal to 0, then we will say equal but real, and less than 0, we will say complex but unequal. Complex, unequal. And when perfect is square, then we will say real, unequal, rational. Actually, nature of the roots we can find out. Nature of the roots we can find out in the discriminant d